Okay, hi, good morning, good afternoon, good evening. We do have a worldwide audience. Happy to have you here. Let me get there we go. Yeah, so this webinar will be recorded. I'm going to try my best to keep it right at 30 minutes. To do that, I have to mute everyone so we don't have to deal with background noises or answer questions during the webinar. However, put your questions in the chat. We will try to answer a few of them at the end, but because time is tight, I'd encourage you to email me any questions and I'll contact you directly. There's a QR code at the end of this presentation. You'll be able to scan that. But I'll also provide you with a PDF of the presentation and with the recording of this webinar. So today is an overview of Kistler, digital weigh in motion, and smart enforcement. I'm going to take certain topics that'll come up during the webinar, and I'll flag them as a future webinar that goes much more in depth, more in detail. But today the presentation flow is fairly simple. I'll start generic with weigh in motion, its purpose, and various applications. And I'll move through the process getting more and more specific, talking about the Kistler weigh in motion, the quartz weigh in motion, the digital technology, specific applications for smart enforcement, and finally some specific projects. So what's the purpose of weigh in motion? I think I could summarize it in three main topics. We need accurate traffic data. The Federal Highway Administration does require traffic data from all states, and this includes weight. So while cameras can catch a lot of the data, they can't catch the weight. We need weigh in motion for this kind of data. Roadway safety is also enhanced, and then also for infrastructure protection. But when we talk about specifically roadway safety and infrastructure protection in relation to weigh in motion, we're really talking about overweight commercial vehicles. So what does this cause? Just some generic answers here. Longer braking distance, even up to 60% longer braking distance. Higher energy consumption, improper load distributions that can lead to tipping around certain curves, tire blowouts, potholes, cupping, and cracking, not just in the roadways, but in particular in bridge decking, and certainly vehicle damage, not just to the truck itself, but to the neighboring vehicles. But the bigger picture here, I think, is maybe twofold. The economy suffers, and it puts people at risk. Various applications of weigh in motion, so WIM can be used either to gather data or to make decisions based on the data that's gathered. I'm just going to focus on two applications in this webinar, and you can see them down at the bottom. Smart enforcement, which I'll define later, and then bridge protection. I'll touch on that. So just a quick list of three basic WIM technologies that are available. You have a load cell or a bending plate, you have strain gauge, and you have Kistler quartz weigh in motion based on quartz technology. All of Kistler's business from its inception in 1950 until now, and in the 25 plus industries that we serve, has been based on the remarkably stable and the consistently reliable properties of quartz. For our weigh in motion, you can see kind of the construction there on the left. Over 60 sensing elements are lined up and down the length of that sensor. But how does that work? How does quartz work? Well, it's a property discovered in 1880s by Pierre and Jacques Curie, and the GIF here shows a compression of a quartz disc. It shows it compressing like a sponge. I can tell you that it's a rock. It does not budge, but when it's subjected to a compressive force, it generates a very, very slight voltage. So just to note, it's not actually moving in the sensor. It's just for the illustration here, which is why I can say that in a Kistler quartz weigh in motion sensor, there are no moving parts. There's nothing that's actually moving there. But a very small voltage is generated by quartz when it's subjected to a compressive force. So Jacques and Pierre, they didn't do much with their discovery. They did build a scale out of it, but the scale was hardly useful because this property of quartz only happens when it is experiencing the compression, not when you hold it. So a scale application doesn't work too well. They didn't do much with their discovery. The voltage was way too small and it wouldn't hold, but 60 years later, Walter Kistler did. The patenting of the world's first charge amplifier to take that very, very small voltage generated by quartz, bringing it up to a level where you could measure it and use it. and therefore then quartz could be used to measure pressure, force, acceleration, and torque, and that has always been the basis of the Kistler business. We, from basically the 50s up into the early 2000s, we concentrate on making literally thousands of different components based on this piezoelectric property of quartz. In 1991, we patented, actually the patent was in 93, but we invented in 91 the world's first quartz weigh and motion sensor. And since then, we are now in 49 states. Maybe the roll tide will catch up sometime. I think they will. We have over 1,000 sites throughout the U.S. and over 80,000 of these sensors installed globally. Our sensors, quartz sensors, come in 3 different classes. From top to bottom, you'll find increasing accuracy and accordingly increasing cost, no doubt. I'm just going to focus today on the Linneus Digital. Just some quick specifications. I can say that analog sensors, those are the top 2 in the previous slide, they provide one signal. They don't know where the tire hit along the length of roughly a 6-foot sensor. They don't know where it hit. They just know that it hit. They don't know if it was a single or dual tire. They just know it got hit. And they give you a voltage signal out of the cable there. But the top line there, each of these sensing elements along the length of a digital sensor is calibrated and digitized independently, and it delivers a uniform signal over the entire sensor length. So when a dual tire goes across this sensor knows it was a dual tire. It sees the gap in the middle. It knows exactly where it hit. When a flat tire goes across the sensor, it knows that the profile is maybe different than its neighbors. So every one of these sensing elements has its own charge amplifier built in, and therefore each one can be calibrated differently. I'll expand on that in just a minute. It has operating temperature range from -40 Fahrenheit to 176 Fahrenheit, quite a wide range there. Axle loads, it can handle from anywhere from 0 to 25 tons, so virtually an unlimited gross vehicle weight. Speed range, anywhere from 2 to 155 miles an hour, and it will measure speed, by the way, at plus or minus 0.6%. The dimensions of this sensor, quite small, 1.8 inches for my American friends, and then 46 millimeters. This is in the width, 2.6 inches deep, and then we sell it in 3 different lengths, 1.5 meters, 1.75, and 2.0. The sensor weight without the cable, and I'll say without the cable because you could order it with a 40-meter cable or a 90-meter cable, are either 15 pounds, 16.8 pounds, 18.7 pounds, really not weighing much at all. The cable is standardized cabling with PoE with RJ45 connectors at the end. So just some quick specifications. I want to give a kind of an overview of some of the benefits. This is the world's most accurate sensor, acquiring an OIML R134 class F5 certification. To describe that to you, just to bring some clarity to it, this sensor has an error rate of plus or minus 2% in verification mode, meaning right after you calibrate, you go to verify the sensors just after calibration, we're getting plus or minus 2%. And then in operation, plus or minus 5%. And some may say, well, that's not that high. Yeah, but this certification is with 100% confidence. So if I were to give you quotes with 95% confidence, I mean, it's incredible how low these numbers would be. So I can tell you with 100% confidence, and it's been proven by the OIML certification, that I'm getting plus or minus 5% in regular everyday operation. That's an incredible achievement. I'll start from the top and go from the top down. We are the least intrusive of any weigh and motion technology. I've already given you the dimensions and the weight of this sensor, so you're not going very deeply into the roadway. Quartz, the accuracy is not affected by temperature changes. So even across that wide range of temperature operability, there's no temperature compensation needed with the quartz technology. And I said earlier, we are maintenance free. We have no moving parts inside of our sensor. There's an advanced tire screening option available. You can do this with our analog product as well. It requires a third row of sensors at an angle. This sensor has the ability built in, so it's an option, it's a license, and it's incredible. So like I said earlier, you can detect a single tire, a super single, a dual, or you see the exact profile of the tire, which is used to determine if one of the tires may be under pressured. Moving up to the right, top right, we have an interlane detection and measuring option. So we're not just going to say, hey, that truck was straddling the lane. We can actually then stitch together the record from the sensors that were used in that particular site. And we'll reconstruct the record based on the sensors that were used and then be able to give a reliable, accurate, just as accurate reading as if the truck had stayed in the same lane. I'll talk more about that one. Our digital weigh in motion interfaces to our Kistler structural health monitoring system. I'll touch that briefly later on. We have the highest weight rating for each axle at 25 tons, and there's built-in health status checking. Now, let me pull just a few of these out and maybe talk a bit more detail about them. So when I say that each of the quartz discs, there are about 60 sensing elements lined up along the length of this sensor. Each one is calibrated separately. What this can do is that it compensates for varying road substructures and bases. So you can see in that far left image, if maybe one side of the road underneath has more crushed gravel than the other side, that's going to make a difference to an analog sensor, and it'll cause some inaccuracy. But this is one of the reasons why these sensors are the most accurate you can get, because by calibrating each side of the sensor, by calibrating each disc itself, you're able to compensate for these variations in the substructure. Now, also this allows me to do a tire screening much more accurate with this kind of sensor. Built-in health status checking. So there are just over 60 sensing elements in each sensor. You can see the diagram there. They're kind of stacked at regular frequencies there, regular intervals. We'll do a more detailed webinar on this later, where we'll dig into this and show some of the data. But in addition to quartz discs used to sense the pressure converted into weight, we have accelerometers, which can detect irregular vibrations, such as a damaged roadway. I like to say our biggest enemy is a snowplow. So if something happens and the roadway is separated, the sensor's moving a bit, it'll know that, and that'll be an indication to go do some repairs to the road. We have temperature sensors built in that monitors the operability range. And then also the user interface will flag if there's any lost signal. So if something happens, there's a flag to let you know that something has gone wrong and needs to be checked. Interlane driving is another one that I'll do a separate webinar. We'll look at some of the data there. This is an intelligent reconstruction of the weigh in motion record when interlane is detected. So like I said before, it's not just letting you know that someone was straddling the lane, which is a typical way to fool a WIM site. If you straddle the lane, most analog sites can't do this. They won't be able to stitch it back together, but the Kistler digital site absolutely will. And so you will eliminate losing records from any attempted invasion of the WIM system. Whether it was intentional or not, you'll be able to stitch the record back. And then another webinar I'll do later in detail is the tire screening. So this sensor has the most accurate detection of tire properties. Again, single, super single, dual, missing tires even. Maybe sometimes we've seen on a dual setup, the inner tires are actually missing, which you can't see it from the outside. It can help identify underinflated tires, and a profile can even show, the profile that the system delivers can even show overinflated tires, which is helpful when you're trying to study damage on bridge decking. Let me move on quickly here. The base system, you have three essential parts of a base system. You have the sensors themselves. I already talked a lot about those. You have the electronics. You can see for a digital system, pretty simple. I'll expand that middle one out in a minute. And then you have your user interfaces, whether it's user or machine. If you look just at the electrical components after the sensors, so the sensors will plug into a power over Ethernet switch or a router there, which plugs into an IPC. You have a standardized computer which handles all of the data processing, and then a router for speaking outside. And then when you install this system, we can sell it on a DIN rail. There you see some loop controller cards added, but we would certainly recommend putting this kind of system in a cabinet with a pre-wired back panel. We recommend that. This would allow for any kind of expansion, which you'll see here in a minute. what kind of data is recorded. You guys are in the WIM industry. This is nothing new. So speed, actual vehicle length, vehicle gross weight, the direction that the vehicle's traveling, which lane they're in, axle loads, axle distance, vehicle class, axle counts, tire type, tire profiling, weight distribution, whether it's tipped to the left or improperly balanced or to the right. These are the kinds of things that it can detect and flag if a violation. But let's come back to the three purposes that I proposed for a weigh in motion site. Why do we need weigh in motion? Well, all right, the data, the accurate data, the roadway safety, the infrastructure protection. There's one application that I think pulls all three of these things together. It's a primary application that ties it all, and that's called smart enforcement. How would I define that? Three main enforcement efforts, plus I would add a corollary, which are bridges. Bridges will be a primary benefactor of any of these enforcement efforts, not necessarily needing to be present, but certainly could be a benefactor if the weigh in motion site is placed near the bridge. So redirection, virtual and direct. Let me define these quickly. So looking at redirection, this is an example of an actual project that we did out in Mexico. I love the sketch. You know, if you weigh too much, you're going to have to go underwater, buddy. But you can see in the picture there the actual pathway, the curvy dirt road there that have to travel on while this bridge was being reconstructed. So if the truck was over a certain weight, it would require the truck to take the path instead of the bridge. So redirection is either lighting up a sign, maybe an arrow or something based on the WIM data, dropping a barricade, sounding a horn, shining a light, or any combination of all this. The WIM data can be used to make that kind of decision and to make an effort to redirect the vehicle. Pretty simple. We'll move on to virtual enforcement. Also, this is used throughout the nation already, but just a quick description of how it could be. Two ways to do it. I'm showing one here. This is where you stage an enforcement officer downstream from the WIM site who would identify the violating vehicle, pull that vehicle over, perform a physical inspection, which would include weighing them on portable scales, and then issuing a citation if necessary. So essentially, in this scenario, the WIM site raises the red flag, an enforcement officer downstream would perform a physical inspection. Another way to do this is instead of an enforcement officer, maybe you have a weigh station and you employ some kind of redirection effort to pull a violating vehicle over into the weigh station where it can be weighed on a static scale. This kind of enforcement, virtual enforcement, is actually already legal in all of our 50 states. A simple kind of explanation of how the data or the process might flow. At the bottom level, you have the WIM record, which is all the data points that I explained earlier that it would gather. In this site, you'd want cameras involved to grab the license plate, the overhead view, the DOT number from the side. And then there's a database that would kind of match these two records into one. So you have the WIM record of all the data, you've got the camera record of the images, all in one record there in a database, and then either through filtering or through another database, you would have the violations. And the violations are usually defined by the actual DOT or the state police. Yeah, so this is just a simple flow. Each of our integrators may process this in a different way. And one example is in Rhode Island. I've given you a link to a press release by the Rhode Island DOT. This particular site was placed near a bridge where they were seeing 140,000 vehicles per day going across it. They suspected a high number of overweight vehicles based on prior inspections that they had performed. They made data public for about 7 weeks in January and February of 2025, and they showed that 2,600 plus, 26,021 trucks over 96,000 pounds were crossing this bridge. Heaviest vehicle they caught was 135,000 pounds. And really cool, and I was pretty excited about it. Some of these vehicles were caught driving in the middle of the lane. So surprise, the digital weigh in motion site there caught it. But a great application there. There's a link in the presentation. You can see their press release and follow some more details about that. But let me move on to direct enforcement. Now, there's a lot of buzz about this nationally. And depending on who I talk to, it's either a cuss word or it's a God-given answer to a very tough situation. And I can sympathize with both. I really can. But in a lot of ways and in many locations, it just makes sense. What is direct enforcement? Very similar to virtual. So you're sending a ticket, though, in this case, to a violating vehicle owner based on the WIM data alone. The human element is not on the road downstream, but instead in an office, maybe back at the state police, maybe back at the DOT, maybe it's a third party performing the operation. But the point is the processing of the data is not done on the road itself, but in a back office operation. Just quickly, there are several countries throughout the world that this is already happening. This is already legal in the country. Brazil came on board in 2024. The most recent one to come on board, actually Vietnam, legal since September of 24. So quite a few countries are already doing this. It's already established and legal. In the U.S., you see some other countries considering it right now, and they're under preparation to begin. In the U.S., we have one enforcement site, direct enforcement site. I'm going to show you some more details about that. And we're also working on a national standard for a weigh in motion site, should it be used for direct enforcement. This is done through the National Council of Weights and Measures. I'm going to throw this one out here. Kistler was a co-author along with New York City DOT and C2 Smart Center to propose this amendment to an existing code book called the Handbook 44. And we introduced a section to deal with weigh in motion used for direct enforcement. How often should it be calibrated? How is it calibrated? What are the performance specs if it's to be used for direct enforcement? I can tell you this measure failed in 2024. It's back up for vote in 25. If you want to know more information about this, I've given you a link there to kind of start some research, or email me. Happy to talk to you about this. But a simple data flow in this process, about the same, starts with the WIM record. You add in the camera records to a database where these are matched together. Maybe then there's a database for violations only, and then this data is processed in a back office operation, usually in coordination with, or it's run by the state police, where they'll review the violation records. They'll use the license plate to identify the vehicle owner and registration and issue a citation. New York City DOT issued a study of this, and it's the only operative site in the U.S. for direct enforcement. So in almost a 1 year period, they issued a total of 2,300 violations, and these violations were challenged. 334 of them were challenged, and they were upheld at a rate of 80%. So 268 of them upheld. The vast majority not challenged at all, accepted, and the fine paid. This site is at the Brooklyn-Queens Expressway. I've given you a few links here to find out some more information about this. But just very quickly, there are 130,000 vehicles per day going across this triple level cantilevered bridge with 130,000 trucks per month. They were seeing that only 20% of these trucks were being ticketed by a virtual inspection effort. And so they knew that direct enforcement was needed. There was no place to pull the truck over. So they got a legislation approved in 2023 for direct enforcement. And in the first 90 days, they just issued a warning, not a citation, but a warning. And in that period, they saw a 64% reduction in overweight vehicles. There's the graph that shows that. In the yellow, you see at the bottom, August, September, October of 23, there's that large reduction. And then citations started in November of 23, and the reduction went even further. So a great success story there. I've given you some links to take a look at that. There is another bridge in New York City coming up for direct enforcement. I can't talk about this monstrosity, but I can show you a lovely impressionistic view of it. But let me move on to bridges being a corollary. I'll go quickly here because there is another webinar about structural health monitoring. So if you take the first step of the weigh in motion, gathering the vehicle weight data and all the other data that a weigh in motion site gathers, maybe the second step, you employ some kind of redirection or enforcement for your violating vehicles. And the third step is a structural health monitoring solution to monitor the movements, vibrations, and strains on the bridges, which you can correlate then with the actual vehicle load going across. I'll skip through that. I'm running tight on time here. So one example is in Rhode Island. I've given you a link there to a RIDOT press release. talks about a particular bridge that's getting information from the weigh in motion site that's nearby and feeding a structural health monitoring system that is watching the bridge movements and the bridge strains, helping them to analyze what's happening on the bridge. Great example there. If you want a demonstration of structural health monitoring, here's a QR code. There's a link also, but again, there's going to be another webinar on this one coming up later this year. Let me bring this all to a close. So starting with Kistler quartz weigh in motion, specifically the digital weigh in motion in our KiTraffic digital application. This is the world's most accurate weigh in motion sensor, and it enables a better level, I think, of smart enforcement, which pulls together the three purposes of weigh in motion, delivering very accurate data, which can be used to analyze traffic patterns, et cetera, but also roadway safety is provided through this and infrastructure protection. Smart enforcement has, I think, these three elements: redirection, virtual enforcement, direct enforcement. If this site is placed near a bridge, then the bridge is an immediate benefactor of that data. And then I will say that our digital products and solutions are available through our trusted and certified integrators. We've worked with these guys for a long time. They also bring their own array of services and benefits to these projects. So contact me directly for more information or for references to one of these integrators. I'm going to close with that. I have a QR code on the screen that'll bring up an email that'll come right to me. Thank you for your attendance. I started talking a little quickly. I saw time running down, but there are still a few minutes for some questions that have come in through the chat. Lucas, you're watching that?
Yes, thank you very much, JT. I'm watching the chat, and maybe I can ask a couple or provide a couple of questions here. So the first question towards you, JT, would be, you talked about all these different sensing elements. So how does a typical calibration of a KiTraffic digital system looks like? Is it more complicated than an analog system?
You know, the only additional complication might be that you might run the trucks over the left side of the lane, the right side of the lane, and in the center of the lane. This gives the calibration across the length of the sensor. I think the question was also how often are they calibrated? What we've seen is this may differ depending on how the WIM site's used. If it's a WIM site simply for data, then maybe you don't calibrate it as often. If you're using it for direct enforcement, this would really depend on your legislation. I failed to mention that to do direct enforcement in your state, you have to have legislation. In the absence of a national standard, which we're trying to create, it's not a national legislation, but a national standard. You'd want to do calibration much more often. I think New York City's doing it every 6 months on their site.
Maybe one short addition here, let's say from a technical or user perspective. So all you as a user really do is execute truck calibrations, right? As you basically already know it from the analog system, and then the calibration, or let's say the distribution of the calibration factors to all the different sensing elements, that's all done by the Kistler software. So for a user, it's really easy. Just select basically the truck runs, press one button, execute calibration, and the whole system will be calibrated by our algorithms.
Exactly.
Second question. So how robust are digital linear sensors compared to analog technology? What is expected lifetime in the road?
Yeah, the expected lifetime, we expect these things to last at least 8 years. I like to say that they'll outlast the roadway in which they're placed. Like I said, there's no moving parts in it. These things usually do not go bad. Our biggest enemy is the snowplow or a roadway that's become damaged. You know, in a well-traveled roadway, you can get a lot of cupping. And so that too can challenge the performance of the sensor, could even cause some damage to the sensor as it gets really, really deep. But these things are quite robust. Again, the highest axle load allowed on this sensor than any other, handling up to 25 tons at each impact. So.
Yeah, and I would think it's not just an assumption, it's also proven. The first digital sensors were installed back in 2018, and we still can access them, and they are still working. So I think that's perfect proof that also sensors with electronics embedded can survive quite long in the road.
Yep. Yeah, that's the one outside the Zurich airport, yes?
Yep, it is. Last question, maybe before we close the webinar. So, is the digital WIM system compatible with the analog WIM system?
Is it compatible? I'll answer it in this way, and I hope I hit the question well. So you cannot plug a Kistler digital sensor into the analog data logger. There's a proprietary interface between the digital sensor and the digital electronics, so namely the IPC. So the industrial computer there is processing all the data from the digital sensors through the router. So you can't interchange the analog sensors with the digital sensors. The electronics have to go with it. The analog data logger, the electronics that come with the analog system, actually that sensor could be used with a number of different data loggers other than Kistler data loggers. This is not so with the Kistler digital. This comes as one package, proprietary interface. Hopefully that answered the question. Lucas, would you have another perspective on that?
No, I think that's right, yeah, JT. So I think the one big benefit of the digital sensor is really that it's not talking anymore to a data logger, that it's talking to a switch and an IPC, right?
Yeah.
So it's not so easy to, let's say, plug in a digital sensor to an analog data logger. But there are ways how those systems can communicate on an upper level.
Exactly. Okay, so we've gone a couple minutes over. Sorry about that. But hopefully you found this to be informative. Again, this was a good overview with a decent level of detail, but I'll take each. We'll make a more detailed webinar digging into certain aspects of the digital way of motion, even into direct enforcement and to structural health monitoring. This round, the attendees here will get a direct invitation for that. So look for those coming up. Thank you for attending. Please send me emails. This QR code will get you right there to my email address, and I'd love to hear from you. Thanks again for attending. Have a great day.